Hello, in this lecture we will find out the area of the semicircle in 4 different methods. In the drawing we have the right triangle, triangle ABC. We know that side BC of triangle ABC equals to 5 units, side AB equals to 12 units, and actually we have the semicircle that is inscribed by triangle ABC, and we want to find out the area of this semicircle. So we'll start with the first method. First of all, we will define the center of this semicircle as point O. Therefore, OB will be the radius of this semicircle because of the fact, so we'll define it as R, that is the radius of this semicircle. Line segment OB starts from the center of this semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, line segment OB is the radius of this semicircle. Okay? And we know that side AB of the right triangle ABC is equal to 12 units, and OB is the radius of the semicircle. So OA will be equal to AB minus OB. Again, OA will be equal to AB minus OB, that is to say, it will be equal to AB, that is 12 units, minus OB, that is the radius of this semicircle, so it will be equal to 12 minus R. And we will also define the touching point between the hypotenuse AC and this semicircle as point D. Point D is the touching point between the hypotenuse AC and this semicircle. In the next step, we'll join together points O and D by a straight line. So actually, line segment OD is the radius of this semicircle because of the fact that it starts from the center of this semicircle, that is to say from point O, and ends at point D, that is a point on this semicircle, so it is equal to R. Okay, and we actually have a rule, I will call it rule number 1. According to rule number 1, a tangent to the radius, a tangent to the circle a tangent to the circle is perpendicular to the radius, drawn to its point of tangency. So I will read rule number 1 again. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and we have a radius of this circle this is the center of the circle. We define it as point O, and we have also a tangent to this circle. Actually, AB is tangent to this circle at this point. We define this point as point M. Point M is the point of tangency. Of tangent AB with this circle. Then we will join points O and M together by a straight line. OM is the radius of this circle. So we define it as R. This is the radius of the circle. So according to rule number 1, a tangent to the circle, that is to say AB, is perpendicular to the radius drawn to its point of tangency. So actually this radius, the radius OM, it is drawn to the point of tangency. That is to say it is drawn to point M, that is the point of tangency. Therefore the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, like in this drawing we have the radius OM, it is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency. Then the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also will be equal to 90 degrees. Okay, so we can implement rule number 1 in our drawing, because in our drawing we have the radius OD, it is drawn to the point of tangency, that is to say, it is drawn to point D, that is the point of tangency of tangent AC with this semicircle. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Why? Because the radius of D, it is drawn to the point of tangency, that is to say, it is drawn to point D, that is the point of tangency of tangent AC with this semicircle. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And we will use the Pythagoras theorem in order to calculate the length of the hypotenuse AC. So in triangle ABC, the right big triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse is AC, so the square of the hypotenuse is AC square. Okay, AC square, and it equals to the sum of the squares of the perpendiculars in the right triangle ABC. It equals to BC square plus AB square. So AC square equals to BC square. It is given us in the question that BC equals to 5 units, so BC square will be equal to 5 square. 5 square is 25 plus AB square. It is given us in the question that AB equals to 12 units, so AB square is 12 square. 12 square is 144. So AC square equals to 144 plus 25. It is 169. We'll take a root out of this equation number 1, and we will get that AC equals to the square root of 169 that is to say, the square root of 169 is 13, so AC equals to 13 units in its length. So we can write here that AC equals to 13 units. So okay, and we can implement the Pythagoras theorem also in the right triangle ADO. But before that, we will focus on triangle ABC, and we will also focus on the right triangle ADO. Okay, so we'll focus on triangle ABC. The big right triangle ABC, and also on the small triangle ADO. Okay, we will actually prove that those two triangles are similar to each other. Why they are similar to each other? First of all, we know that those two triangles are right triangles. So that is to say, angle ABC of triangle ABC is equal to angle ADO of the small right triangle, triangle ADO. And both those two angles are right angles, they are both equal to 90 degrees. So this angle is right angle, it is given us in the question, and we proved according to rule number 1, this is also a right angle, angle ADO is a right angle, so found out that angle ABC equals to angle ADO, and they are both equal to 90 degrees. And here we have also a common angle. This angle is a common angle, so it is actually angle BAC. Angle BAC that belongs to the big right triangle, triangle ABC, is equal to angle DAC, is equal to itself, because it is a common angle, equal to angle DAC of the small right triangle. It is equal to angle DAO actually. Is equal to angle DAO. It's a common angle that belongs to both triangles. We can also simply say that angle A equals to itself, but this, in this way I emphasize that this angle, it is actually an angle that belongs to both triangles. It belongs to the big right triangle, triangle ABC, and angle A also belongs to the small right triangle, triangle ADO. So angle BAC of the right triangle, triangle BAC equals to angle DAO. It is the same angle that equals to itself. But because of the fact that it belongs to both triangles, you can say that the angle equals to itself, because the angle that belongs to triangle ABC equals to itself, but it is also belongs to triangle DAO. Okay, and here angle ACB of triangle ABC is equal to angle AOD of the small triangle AOD. Write it down. Angle ACB of the right big triangle, triangle ABC is equal to angle AOD of the small triangle. So those two angles are equal to each other according to third angle theorem. So angle ACB equals to angle AOD, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem says that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. So, and we actually found out that those two angles in the big triangle, triangle ABC, congruent to those two angles in the small triangle ADO. Therefore, this is the first pair of angles that must also congruent. That is to say, those two angles must also congruent to each other. Okay? So we actually proved that all the angles of the big triangle ABC congruent to all the angles of triangle ADO. Therefore, we proved that triangle ABC is similar, this is the sign of similar, to triangle ADO according to angle similarity rule. We'll repeat again. We proved the triangle ABC, the big right triangle, is similar to the small right triangle, triangle ADO, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles of another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that the two triangles are similar to each other, we will conclude that AO over AD equals to BA over AC. Okay? DO over AO, DO over AO is equal to BC over AC. I will repeat again, from the fact that triangle ABC is similar to triangle ADO, we will conclude that DO over AO equals to BC over AC. Okay, DO over AO equals to BC over AC. So DO is the radius of the semicircle, it equals to R. AO, we already found out that AO, side AO of the right triangle equals to 12 minus R. And it equals to BC. BC equals to 5 units. It is given us in the question. And we have already found out that the hypotenuse AC of the right triangle, triangle ABC equals to 13 units. Okay, so we have one equation with only one variable that is missing, that is actually the radius of the semicircle. So it is very easy to find out the radius of the semicircle. We will cross multiply this equation number 2, and we will get that R equals to 5 times 12 minus R. We will open the brackets in this side of equation number 2, and we will get that 13R equals to 5 times 12 is 60, minus 5 times R is minus 5R. We will add 5R to this equation number 2, and we will get that 18R equals to 60. We will divide this equation by 18, and we will get that the radius of the semicircle equals to 60 over 18. We will divide the numerator and the denominator by 6. We will get that 60 over 6 is 10. 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units. And the area of a semicircle is equals actually this bracket is the sign for the area. It means the area of the semicircle. It equals to pi r square over 2 because it is half of a circle. Therefore we will divide the area of the circle that is actually pi r square by 2. So we will put the value of r that is 10 over 3 inside r in this equation, and we will get that equals that the area of the semicircle equals to pi, and r is 10 over 3 square over 2. Ten over 3 square is 100 over 9. So it is pi times 100 over 9, all divided by 2. Here 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. I repeat again. The area of this semicircle, it equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? So, we'll continue with the second method. We'll find out the area of this semicircle according to a second method. We have already found out that the hypotenuse of this triangle is equal to 13 units, so I will not repeat on it. And we defined in method 1 the center of this semicircle is point O. This is point D. And we have already found out that DO, line segment DO, is the radius of this semicircle, and this angle equals to 90 degrees according to rule number 1. I will not repeat on it. And OB is the radius of this semicircle. And in method 1, we have already found out that AO equals to 12 minus R. I will not repeat on it. And okay, so we have rule number 2. According to rule number 2, I call it rule number 2, but you can also call it two tangents theorem. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. I repeat again on rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or two tangents theorem? The meaning of rule number 2 is that if we actually have a circle and we also have this point P. Point P is defined as an external point because of the fact that point P is not located inside this circle nor on this circle, but it is located outside this circle. Therefore, it is defined as an external point in relation to this circle. So if from the external point, point P will draw two tangents to this circle, so the first tangent will be this tangent, and we will define the touching point between the first tangent and this circle as point A, and we will also draw from point P second tangent to this circle, and we will define the touching point between this second tangent and the circle as point B. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So the length of this first tangent is PA, and the length of the second tangent is PB, as you can see from the drawing. It equals to PB. And according to rule number 2, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P, that is a common external point, to a circle, to this circle, are equal. So the length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 2, the lengths of those two tangents are equal to each other, that is to say PA equals to PB. Okay, so whenever you draw two tangents from a common external point of a circle to that circle, then the length of those two tangents will be equal to each other. In this case, PA will be equal to PB. So we can actually implement rule number 2, two tangents theorem in our drawing, because in our drawing we have the external point, point C is an external point in relation to this semicircle, because it is not located inside the semicircle nor on this semicircle, but it is located outside of this semicircle. So it is an external point of this circle. And from point C, we have two tangents to this circle. We have the first tangent is CD, and the second tangent is CB. And according to rule number 2, they are equal to each other. Because whenever you have from an external point two tangents to a circle, then they are equal to each other. That is to say, CD equals to CB. Okay, according to rule number 2, CD equals to CB. CD equals to CB according to rule number 2 or two tangents theorem. Okay, CD equals to CB. But it is given us in the question that CB equals to 5 units. CB equals to 5 units, or BC, it is the same. It equals to 5 units, so we can write here that CB equals to 5 units. So from this equality we will conclude that CD also equals to 5 units. CD equals to 5 units. So we can write here that CD, this 9 segment, equals to 5 units. But we have already found out that the hypotenuse AC equals to 13 units. So AC minus CD will be equal to AD. Again, AC, that is the hypotenuse, minus DC will be equal to AD. AC is 13 units, DC is 5 units. So 13 minus 5 is 8 units. So AD equals to 8 units. Okay, now we can implement the Pythagoras theorem in the right small triangle ADO, and we'll find out the radius, that is the only missing variable. So if we focus on the right triangle ADO, this right triangle, in the right triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in this small right triangle ADO, in the green right triangle ADO, you can clearly see that the hypotenuse is the side that is located in front of the right angle. That is to say, it is actually AO. So the square of the hypotenuse is AO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AD squared plus DO squared. I'll repeat again. In the right green triangle ADO, according to the Pythagoras theorem, AO square equals to AD square plus DO square. AO square equals to AD square plus DO square. So AO is 12 minus R, so you can see here AO is 12 minus R, so A all square is 12 minus R square, and it equals to AD square. AD is R, so AD square is R square, plus D all square. No, AD is 8 units, so 8 square is 64, plus D all square. D all is the radius. D all square will be equal to R square. So in conclusion, we found out that 12, according to equation number 2, 12 minus R square equals to 64 plus R square. We will open the brackets in this side of equation number 2, and we will get that 12 minus R square is 12 square is 144, plus R square minus 24R, and it equals to 64 plus R square. Here we have R square in both sides of equation number 2, so R square will get cancelled. And what is left after we cancel R square? What is left is, from equation number 2 is 144 minus 24R equals to 64. We will subtract 64. We will subtract 64 from this equation number 2, and we will get that 144 minus 64 is 80, and minus 24 equals to 0. We will add 24R. It is actually minus 24R equals to 0. We will add 24R to this equation number 2, and we will get that 80 equals to 24R. We will divide this equation by 24, and we will get that R equals to 80 over 24. We will divide both the numerator and the denominator of this number by 6. We will divide it by 8. We will divide both the denominator. We will divide the numerator and the denominator of this number by 8. 80 over 8 is 10. And 24 over 8 is 3. So we found out that R equals to 10 over 3 units. So, and the radius of the semicircle and the area of the semicircle is pi R square over 2. That is actually pi R is 10 over 3 square over 2. It equals to 10 over 3 square is 100 over 9 times pi over 2. 100 over 2 is 50 pi over 9. So we found out that the area of the semicircle, according to the second method, equals to either 50 pi over 9 square units. So in terms of numbers, it equals to 17.45 square units. Okay, we finished with the second method. In the next step, we'll find out the area of this semicircle according to a third method. We have already found out that AC equals to 13 units, the hypotenuse, and we will draw a mirror image of this figure. I'll repeat again. We will draw a mirror image of this figure, and we will get that So here we will define this point as point D. So this triangle ABD is the mirror image of triangle ABC. This is exactly the same image, but a mirror of it. And therefore AC will be equal to AD equals to 13 units. And here we know that BC equals to 5 units. So DB will be equal to BC because it is a mirror image. So DB will be also equal to 5 units. And 5 plus 5 is 10. So DB equals to 10 units. So here, so if we focus, so and we know also that according to rule number 1, those two angles are right angles. So actually AB is the height of triangle ABC when the base is CD. So the area of this triangle ADC, the big triangle ADC, will be equal to the area of triangle ADC will be equal to the base of the triangle times the height to the base over 2. The base is CD, that is 10 units. The height is AB. It is given us in the question that AB equals to 12 units over 2. 10 times 12 is 120 over 2 is 60. So we found out that the area of triangle ADC is equal to 60 square units, and the semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. The perimeter of triangle ADC is equal to AD plus DC plus AD plus DC plus AC. That is the perimeter, but we want the semi-perimeter. Semi-perimeter is the perimeter over 2, so we will divide it by 2. So what is the semi-perimeter of triangle ADC? It equals to AD. AD is 13 units plus DC. DC is 10 units plus AC. AC is also 13 units over 2. 13 plus 13 is 26. 26 plus 10 is 36. 36 over 2. 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18 units. And we know that whenever you have a circle that is inscribed by a triangle, like in this drawing, then the radius of any circle that is inscribed by a triangle, it equals to the area of the triangle over the semi-perimeter of the triangle. Okay, the radius of the circle that we are looking for, it is 2 times our semicircle. The circle equals to 2 times our semicircle, so the radius equals to the area of triangle ADC over the semi-perimeter of triangle ADC, and we have already found out that the radius of triangle ADC equals to 60 units and the semi-perimeter is 18 units. 60 over 18, we will divide both the numerator and the denominator by 6. 60 over 6 is 10, 18 over 6 is 3, so we found out that the radius is equal to 10 over 3, and the area of any semicircle is equals to pi r squared over 2. Here pi r is 10 over 3, 10 over 3 square over 2. So it is pi times 100 over 9 over 2. 100 over 2 is 50. Pi over 9 square units, so in terms of numbers it equals to 17.55 square units. We finished with the third method. In the next step I will present to you how to find the area of this semicircle according to the third method. We have already known that AC equals to 13 units, the hypotenuse of triangle ABC. We have already found out that here it is D, the center is O, DO is the radius of the semicircle, and we know that those two angles, they are right angles according to rule number 1. And here OB is the radius of the semicircle. We have already found out that OA or AO equals to 12 minus R. DO, it is of course the radius of the semicircle. And we will define angle CAB as theta. Okay, we defined angle CAB as theta. We will focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, sinus theta on the right big triangle, triangle ABC, sinus theta equals to CB over AC. CB equals to 5 units, and we have already found out that AC equals to 13 units. So according to equation number 1, sinus theta equals to 5 over 13. I will repeat again. Sinus theta, according to equation number 1, equals to BC over AC. BC is 5, AC is 13. So in conclusion, we found out that sinus theta equals to 5 over 13. We will focus on the small right triangle, triangle ADO. In the small right triangle, triangle ADO, sinus theta equals to OD over OA. I repeat again, on this right triangle, sinus theta equals to OD over OA. In the right triangle ODA, sinus theta equals to OD over OA. OD equals to R, it's the radius of the semicircle. OA equals to 12 minus R. Okay, so we have two expressions for sinus theta. We know that sinus theta equals to 5 over 13 according to equation number 1, and sinus theta according to equation number 2 is equal to R over 12 minus R. So sinus theta from equation number 1 equals to sinus theta from equation number 2. Okay, so in this way we'll create the third equation that states that sinus theta from equation number 1 equals to sinus theta from equation number 2. So sinus theta from equation number 1 is 5 over 13, and it equals to sinus theta from equation number 2, that is actually R over 12 minus R. We'll multiply this equation, equation number 3, we'll cross multiply this equation, equation number 3, and we will get that 5 times 12 minus R equals to 13R. We will open the brackets in this side of equation number 3, and we will get that 5 times 12 is 60 minus 5R. It equals to 13R. We will add 5R to this equation, equation number 3, and we will get that 13R plus 5R is 18R equals to 60. We divide this equation, equation number 3 by 18, and we will get that the radius of the semicircle equals to 60 over 18. We will divide both the numerator and the denominator of this number by 6. 60 over 6 is 10. 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units. And the area of the semicircle is pi r squared over 2. So it is pi r is 10 over 3 squared over 2. It equals to pi 10 squared is 100. 3 squared is 9. All divided by 2. 100 over 2 is 50. So it is 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so that is the area of the semicircle according to the third method, according to the fourth method. Now I will summarize the lecture. Actually, we wanted to find out the area of this semicircle. We found out the area of this semicircle in 4 different methods, and in the first method, we presented to you rule number 1. we defined the center of this semicircle is point O. We defined the touching point between the hypotenuse AC and the semicircle is point D. OD, we join points O and D together by a straight line. OD is the radius of the semicircle. OB is also the radius of the semicircle. OA equals to AB minus OB, that is to say it equals to AB, that is 12 units, minus OB, that is R, or OA equals to 12 minus R. And we have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and tangent AB is tangent to this circle is point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM. So you can see here that the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, this radius will be perpendicular to the tangent, or the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees. And we actually implemented rule number 2 in our drawing. In our drawing we have the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent CA with this semicircle. Therefore this angle, therefore the tangent CA will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, then in triangle ABC, according to the Pythagoras theorem, AC square plus BC square equals to AB square. AC square equals to AB square plus BC square, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So AC square equals to BC equals to 5, so BC square is 5 square, 5 square is 25, AB is 12, so AB square is 12 square, 12 square is 144, so 25 plus 144 is 169, so in conclusion we found out that AC square equals to 169. We took a root out of this equation, equation number 1, and we found out that AC equals to the square root of 169. The square root of 169 is 13. So we found out that the hypotenuse AC of the right triangle, triangle ABC, is equal to 13 units. Then we actually proved that the big right triangle ABC is similar to the small right triangle, triangle ADO. Why they are similar to each other? Because we have angle ABC that equals to angle ADO equals to 90 degrees. Those two angles, they are both right angles, they are equal to each other. We have angle BAC equals to angle DAO, it is a common angle. This angle is a common angle that belongs to both triangles. It belongs to the big triangle, triangle ABC, and then this angle, it also belongs to the small triangle, triangle ADO. So this angle equals to itself. And those two, angle ACB equals to angle ADO. Actually, those two angles, they are equal to each other according to third angle theorem. What is third angle theorem? If you have two angles in one triangle that can go into two angles in another triangle, then the third pair of angles must also can go in. And we found out that those two angles in triangle ABC, the big triangle, congruent to those two angles in the small right triangle. Therefore, we have here two pairs of angles that congruent in those two triangles. Therefore, this is the first pair of angles must also congruent according to further theorem. So those two angles are equal to each other according to further theorem. So we found out that all angles inside triangle ABC congruent to all the angles inside ADO. Inside triangle ADO. Therefore, we proved that triangle ABC is similar to triangle ADO according to angle similarity rule. Okay, from the fact that the triangles the triangles are similar to each other, we will conclude that DO over AO equals to BC over AC. Again, DO over AO equals to BC over AC, okay? DO over AO equals to BC over AC. DO equals to R. AO equals to 12 minus R. BC equals to 5 and AC equals to 13. We cross multiply this equation number 2, and we got that 13R equals to 5 times 12 minus R. We open the brackets here and we found out that 13R equals to 60 minus 5R. Here we added 5R to this equation number 2, and we found out that 18R equals to 60. We divided this equation number 2 by 18, and we found out that R equals to 60 over 18, that is actually 10 over 3. So we found out that the radius of the semicircle equals to 10 over 3, and the area of any semicircle equals to pi r squared over 2. So pi r is 10 over 3, so r squared is 10 over 3 squared over 2, all divided by 2. 10 over 3 squared is 100 over 9, and 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. Then I presented to you how to find out the area of the semicircle according to a second method. According to the second method, we actually found out the area of this semicircle. We know that AC is 13 units, and we have already method number 1. We found out that OD is the radius, and this angle equals to 90 degrees. This angle also equals to 90 degrees. OB is the radius, and OA is 12 minus R. And then I presented to you rule number 2. What is rule number 2? Rule number 2 states that it is actually two tangents theorem, or rule number 2, it is the same. The lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or two tangents theorem? The meaning of rule number 2 is that if we have this circle, and from the external point P we draw two tangents to this circle, then the lengths of those two tangents will be equal to each other. Okay, point P is an external point, and from point P we draw two tangents to this circle. The first tangent is PA, the second tangent is PB, and according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, PA is equal to PB. And we actually implemented rule number 2 in our drawing. In our drawing we have the external point C. We have two tangents, tangent CD and tangent CB. According to rule number 2, whenever you have two tangents from external point of the circle to that circle, then the lengths of those two tangents will be equal to each other. That is to say, CD equals to CB. CD equals to CB, according to rule number 2, but we know that CB equals to 5 units. Here CB equals to 5 units. So from this equality, from this equation, we conclude that CD also equals to 5 units. CD also equals to 5 units. So CD equals to 5 units. CA equals to 13 units. CA minus CD equals to DA. CA is 13. CA is 13. CD is 5. So CD, that is 13, minus CD, this is 5. 12 minus 5 is 8. So AD equals to 8 units. And then in the right green triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to AD square plus DO square. AO square equals to AD square plus DO square. AO equals to 12 minus R. AD equals to R. And DO equals to R. And AD equals to 8 units. So AD equals to 8 units. 8 square is 64. DO is R, so R square. DO square is R square. AO equals to 12 minus R, so 12 minus R square. AO square is 12 minus R square. So we got to this equation. We open the brackets here. 12 minus R square is 144 plus R square minus 24R. And it equals to 64 plus R square. We have R square on both sides of equation number 2, so R square will get cancelled. Then we have here 144 minus 24R equals to 64. We subtracted 64 from this equation number 2, and we got that 100 minus 24R equals to 0. We added 24R to this equation number 2, and we found out that 80 equals to 24R. We divided this equation by 24, and we got that R equals to 80 over 24. We divided both the numerator and the denominator by 8. 80 over 8 is 10, and 24 over 8 is 3. So we found out that the radius equals to 10 over 3 units, and the area of the circle is pi r square over 2. Pi r square over 2 is actually 50 pi over 9, or 17.45 square units. So we finish with the second method. Then I presented to you how to find out the area of the semicircle according to a third method. According to a third method, actually according to a third method, we draw a mirror image. We draw a mirror image of this figure. We draw a mirror image of this figure, and the mirror image of this figure is this drawing. Okay, the mirror image of this figure is this figure. So both of them are connected together, and we get here a circle with triangle ADC. And in triangle ADC, we know that AC equals to AD equals to 13 units, AB is 12, and BC is 5, and BD is also 5. So BDC is equals to 5 plus 5, that is 10 units. So here we can actually we also know that according to rule number 1, both those two angles are right angles. So actually AB is the height to the base of triangle ADC. So we have the base that is BC, the height is AB. So we actually can calculate the area of triangle ADC. The area of one triangle is the base times the height over 2. The base is BC. The height is AB divided by 2. BC equals to 10 units. The height AB equals to 12 units over 2. So it is actually the area of triangle ADC, the triangle ADC equals to 10 times 12 over 2. 10 times 12 is 120. 120 over 2 is 60. So we found out that the area of this big triangle ADC is equal to 60 units. And the semi-perimeter of any triangle is equal to the perimeter over 2. And the perimeter of this triangle ADC is AD plus AC plus DC, or AD plus DC plus AC. And the semi-perimeter will be equal to the perimeter over 2, so we divided the perimeter by 2 in order to get the semi-perimeter, and we found out that the semi-perimeter equals to AD plus DC plus AC over 2. AD is 13, DC is 10, and AC also equals to 13. So in conclusion, we found out that the semi-perimeter of this triangle ADC is equal to 13 times 13 plus 10 plus 13 over 2. 13 plus 10 is 23. 23 plus 13 is 36. And 36 over 2 is 18. So the semi-perimeter of this triangle is 18 units, and the area of this triangle is 60 units. Triangle ADC, the area of triangle ADC is 16 square units. Okay, and we know that whenever you have a circle that is inscribed by a triangle, then the radius of this circle will be equal, like in our drawing, we have this circle is inscribed by triangle ADC, and whenever you have a circle that is inscribed by a triangle, then we can find out the radius of that circle that is inscribed by a triangle according to the formula that the radius will be equal to the area of the triangle that is inscribed that blocks the circle over the semi-perimeter of the triangle that blocks the circle. And we found out that the area of this triangle ADC that blocks this circle equals to 60 units, and the semi-perimeter of this triangle that blocks the circle equals to 18 units. So 60 over 18 is the radius of this circle that is inscribed by the triangle, that is blocked by the triangle. Okay, and we found out that the radius of the circle that is inscribed by a triangle is equal to 60 over 18, that is to say to 8 over 3 units, and so the radius of the circle is equal to 10 over 3 units, and therefore the area of the circle will be equal to pi r2 pi r square over 2, and r equals to 10 over 3. So the radius, so the area of the semicircle is equal to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, and then we found out the area of the semicircle according to a fourth method. In the fourth method, we actually defined the angle CAB as theta, and we know that if we focus on triangle ABC, sinus theta equals to CB over AC. Triangle ABC, the big triangle, sinus theta equals to CB over AC. And CB equals to 5 units and AC equals to 13 units. CB equals to 5 units and AC equals to 13 units. So sinus theta, according to equation number 1, if we focus on triangle ABC, is 5 over 13. And if we focus on the green triangle, triangle ADO, sinus theta will be equal to DO over AO, will be equal to DO over AO, DO equals to R, and AO equals to 12 over R. So DO equals to R, and AO equals to 12 over R. So we can create the third equation that states that sinus theta according to equation number 1 must be equal to sinus theta according to equation number 2. So sinus theta according to equation number 1 equals to 5 over 13. And it must be equal to sinus theta according to equation number 2, that is actually R over 12 minus R. Okay, this is equation number 3. Sinus theta according to equation number 1 is 5 over 14, and sinus theta according to equation number 2 is R over 12 minus R, and they are equal to each other. We cross multiplied this equation number 3, and we found out that 5 times 12 minus R equals to 13R. We open the brackets here. 5 times 12 is 60, 5 times minus R is minus 5R. So in conclusion, we found out that 60 minus 5R equals to 12R. We added 5R to this equation number 3, and we found out that 12R plus 5R is 18R. 18R equals to 60. We divided equation number 3 by 18, and we got that the radius equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle equals to pi r square over 2. So pi r is 10 over 3, and r square is 10 over 3 square over 2. 10 over 3 square is 100 over 9. So it is actually pi times 100 over 9 over 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 times pi over 9 square units, or in terms of numbers, according to the fourth method, the area of the semicircle equals to 17.45 square units. Okay, so in this lecture we actually found out the area of the semicircle in 4 different methods, and okay, thank you very much.